Hello, this is Richard Anthony Marca, and this is the sixth assignment for CSC313 for the cell shading assignment 3.7-2, where we implement toon outlines with silhouette detection. As you can see, this is the file, the Java file. Here is the sphere object that we had before. When we did the class path for the Java file, you can see there is different created stuff. I added this here just in case. This is the lightweight Java gaming library with all the stuff in there. I'm not going to go through that. Settings for JSON files and stuff that was created by the class path. So most of this stuff hasn't changed up here. When we get down to this area, this is a change, the render outline model that my teammate made. We'll go over that later. And let's just get to showing how this works. So it's not just, we don't run it as, running it doesn't really do much. As you can see there, I tried running it and nothing happens. So we actually do this via the terminal. And if I copy and paste the code that's right here, and I press enter, have that go down a bit. Model loaded successfully. GLFW window created successfully down here. And this is the file which has the toon shading, which unlike the original, which I will show the original here, this is the, with all the lines on every single face of the triangle. This one has the one in the background, just to make it look nicer. You kind of have the faces. However, instead of just solid black lines, it only renders the outlines when the angle between the normal and the camera view directions exceed a specific threshold. So you will see down, most of our changes are going to be down in the render outline mode. And that is it for the code demonstration. And here's the Word file. As you can see, in the stuff in blue is stuff that has not been changed. None of the stuff is really different. If we go down to the next page should be a few more pages. And then here's the first difference is we added a comment here to kind of match these, makes it look nicer. But we also added the render outline model to render the outline with little extra comments here and there to match the render model. I'm not going to go into too much detail about that one because my partner did that. Then we go to the render outline all the way down here. And the render outline is where all the changes are at. So the first part was more of my second partner, and the second part was more of me, but I will go over it. So creating the render outline model, we have both the back face calling and the front face. So you're going to see the stuff for both back and front as I have here. This part I actually did because it goes with the part in the bottom to render the outlines as wireframes instead of just the back face. So they created a new scale, new shading model, blend, call face, source alpha, GL1 minus source alpha, triangles. The depth mask is set to false, and the call face is GL front. We decided to keep the GL disable in there because it didn't really change anything. In the line width to have the set thickness of the lines. and color for the outline. Getting the camera position, that was something we put in because when we originally did it, we weren't getting the sphere because the camera was the wrong way. So we wanted to make sure that the camera is in the correct position. So here's like float normal to calculate the normal faces. And if normal is null, you just skip it and continue. Calculate the view direction for the first vertex of the face. This is to help make sure that we're looking in the correct direction. So we have the model.vertices get face, float vertex, similar to something in the book that's down there. I will explain later. View direction, camera position with vertex 1, 2, and 0. And the view direction length is just the version of the Pythagorean theorem, where you know a squared, b squared, c squared. Just get the square root of it. And those are all just different view direction lengths. And this is the part I worked on, where calculate the dot product between the normal and the view directions. So the dot product is going to be normal times view is going to be normal times view plus normal times view plus normal times view of each vertex. So it's kind of like length times width times height, but you add them all to each other. So yeah. Render the outlines if the angle between the normal and the view direction exceeds the threshold. So render the outline if the angle between the normal and the view direction exceeds the threshold. And the threshold is going to be 0.3f, so like about a third. And we could adjust that as needed, but we decided as a group that this is the nicest looking one. If the dot product is less than the threshold, and this is actually from the book, but we put it in a different area for the invalid vertex index warning, if that's the case. And this is similar to the one in the book, but the one in the book has it as float vertex equals this. Well, we can't do that because if we go up here, we used float vertex already, so we can't use it twice. So instead of vertex 0, 1, and 2, it's V 0, 1, and 2. And this is for the end of the outline rendering, the GL end, which is the same, but we also, for the end, have depth mask as true. The call face is now at back. GL disabled the call face, and GL disabled the blend. And for the polygon mode, it's almost the same, but we also added, it is almost the same, but I added the front and back because we have both the front and the back on this one. And the rest is exactly the same with changing the formatting. Like there were some extra spaces and stuff, but that's the actual code itself is the same. And that is the end of this video. Thank you for watching.